Hello. Good evening. Oh Lord, I left my own audio on. That's the worst. Okay. Alright, welcome to another stream of this NES Emulator Challenge. Something is different today. Instead of coffee, I have wine. Alright, let's get going. So, we have a bunch of opcodes implemented. I think 19 it looks like. I think that there are like 130 of them. So, this might take a while, but let's get going. 78 is what we're on, which is set interrupt disable, which again is just set a flag, so we can do that easily enough because we laid some groundwork. So the interrupt enable flag is 4. Add it to our flags register. Time for some good time. I hope so. Also, hi Lala. Okay, so all we have to do for this is go and check, for example, set carry, and just drop this in here, and it's exactly the same except it's an I. Bytes 1, cycles 2. It's all good to me. Have to actually implement it, so that's not going to work. Okay. So we got to change this to SEI, and then add the opcode, which is 78. So for anyone who's just tuning in, this is a challenge from Cy in the EmuDev Discord to write an NES emulator which is capable of running Super Mario Bros. 3 in less than 2 weeks. So far, we've got the beginnings of a nice little 6502 emulator. It's got sort of an odd architecture. It's based on a queue of microcode operations instead of instruction by instruction emulation. This is probably overkill for the purpose at hand, but I want to do an N64 emulator later, and I think that will really benefit from this architecture. Alright, next is set decimal, which is again exactly the same, except it's F8. Yes, F8, and the flag is presumably 8. Which flag are you? I know that there's a jump at some point, so let's go ahead and just check what this document here has to say. Decimal flag is in fact 8, so easy enough. D, we've got sed, copy the SCI opcodes, or microcode rather, sed, flag D, and there we go. Been streaming for 5 minutes, I've already implemented 2 instructions. That's the advantage of this architecture. Although I should probably double check that I'm actually doing things right, huh? So that was SEI, SED, and then this is going to be 8, which I think is probably like another one of the set something opcodes. 08. Oh, it's push status. Okay, so that'll be a little more complex. But we have here somewhere. Here? No. Here. We have a listing of all of the sort of steps that this thing should go through. And so if we just go down here, SEC, SEI, SED, PHP. Looks good to me. The golden log. Yes, indeed. I don't know. Actually, I do know what I'm going to do as soon as I am done with NES tests and don't have a golden log anymore. But it will not be as easy. Do I have push? I feel like I already wrote a push routine, but I guess that was for jump stack, or jump to subroutine. So let's just go ahead and do PHP. Is that what it was called? Yep, PHP. What do you do, PHP? Cycles 3, push a copy of the status flags onto the stack. Okay. Let's just check it out in here, get the microcode operations. Always pushes break as a 1 in the 6510. Does anyone know if that applies to the NES at all? Processor makes a logical OR. Did not give any reasons. Okay, well. Okay, so fetch and increment is actually at the end. Fetch next instruction byte and throw it away. So that's just going to be, let's go ahead and copy this. Fetch instruction byte and throw it away is fetch to IDL. And then push register on the stack decrement S. So we're going to push reg names P, which should already be there. And then we should be done. Alright, no op, just fetch and push, and that'll be PHP. And that should be good enough. Alright, invalid instruction 29. So if you look at the next thing, do I already have a PLA instruction implemented? I don't remember doing that, so I'm surprised that this didn't stop here, but maybe I did. Who knows what instructions I've implemented, frankly. Nope, I didn't think I had a PLA. Do I have one that's 68? No. So what happened here? 8, 68. If I'm supposed to throw that instruction away, which is what this document claimed, then there is no way that I would get this instruction, right? Just double check that I didn't do something stupid. No, we do decrement, we do the right thing here. Read next instruction byte and throw it away. Does not seem like the right thing here, because if we look at this trace log, it shows 8 and then 68 as being consecutive addresses. And if I fetch this and then I fetch the next instruction byte and throw it away, there's no way I would ever get this instruction. So the question is the log wrong or is this document wrong? Let's see when this log does PHA, which that claim should be the same. And again, we get PHA PLP. What does PLA even do? Pull accumulator, pulls an 8-bit value from the stack and into the accumulator. Okay, well that makes sense as the next opcode in the thing, because then you're going to just check it here and branch if it fails. So I think probably we just don't do the fetch. And I'm going to make a little note here, which is deviations from documentation, and this is going to be push pre-increments instead of breaking into another cycle, which is something I did yesterday. And then also no fetch and throw away for PHP PHA. And now we should get 68 as our next instruction. Yep, 68, as it should be. Okay. And now 68 is going to be PLA, obviously. Pull accumulator. 4 cycles does set the 0 and negative flags. Interesting. Okay. I wonder if that is also true of RTS, actually. Let's just double check that real quick. RTS, set from stack, not effective. Okay, interesting. Means I may need to implement a pull with flag microcode. Okay, so PLA. Let me just split this so I can, or actually not this one. I don't want to split this one. I want to split the other one so that I can just look at both the opcodes, which is up here, PLA 60, and in here where I'm actually going to implement them. So PLA is going to be fetch opcode increment PC, another fetch instruction byte and throw it away, which I'm sort of skeptical of, but okay, let's start with that. Then we're going to increment S and pull a register from the stack, which the way that I implemented that was no op and then pull. And it's supposed to pull into the accumulator, which makes sense. Now, do I set flags? I do not. So let's go ahead and make a pull with flags opcode. With flags. So this will be exactly the same as the pull opcode, except it will update the, what did we say, the 0 and the negative flags. PLA, pull accumulator, set if A is 0, set if bit 7 of A is set. 0 and negative. Okay, so I do actually already have that implemented in here somewhere. CPU.regs.p is going to be set in here somewhere. Can't remember where. There we go, right here. So the difference here is that instead of val, or instead of loaded, we're going to have val, but other than that, it's exactly the same. Okay, go. 4 windows. Yeah, well, 4 Vim splits anyway, which is basically the same thing. See, again, there's a fetch that doesn't make sense here, because if we look at SLA, or PLA rather, which is right here, then this is the next operand is 29, which is exactly what you would expect it to be, and EF doesn't make any sense. I think it's probably an unimplemented no-op or something like that. So I don't think we actually are doing the throwaway thing here either. The question is, does it still take 4 bytes, or 4 cycles rather? Yes, it says that it does. Which, yeah, that is that. What else did I just change? I changed PHP. Is that supposed to take 3 cycles? Yes, it is. So again, we'll just stick a no-op in at the beginning. Now we should get the AND opcode, which is 29. Right? Yep, and 29 EF. Hi, Pixel, by the way. I spoke to you and then didn't actually address you. Sorry for my rudeness. Okay, so that's AND immediate, which just gonna go ahead and do this. At some point, I will have to like sort these opcodes, but whatever. LDX immediate is right here. Oh, that's right, I have fetch and update flags already. I wonder if I could use that instead. No, probably not. Because fetch is specifically for the PC. Okay, so, and immediate. Let's just pull that up. I gotta drag this over closer to the reference stuff. Reference, that thing, right in order. Too many versions of AND. Come on. There we go. Okay. Absolute addressing, 0 page addressing, 0 page index addressing, absolute index, index indirect, indirect index. Boy, that's a lot of different things. All right. Immediate. I know that I've found this before. There is a description of it in here somewhere, but whatever. Who cares? I've got enough information. All I need to know is that it's 2 cycles and 2 bytes. So it will look exactly like this, except it won't fetch it into X. So what is AND? A logical AND is performed bit by bit on the accumulator contents using the contents of a byte of memory. So here's the question. Do we do an AND opcode? Like, where would the data go to be operated on? Presumably directly into the ALU, because this is only going to take 2 cycles. One of them is it's basically fetch and. So I think we need to just call it AND against the accumulator. Should probably change the name to AND. And then we're going to add it up here. Next to fetch and update flags, I guess. And we'll just call it AND with the reg name. I don't know if there's any version of this that takes any registers other than the accumulator, but I guess that's fine either way. And then, again, we're going to base this on load with flags, fetch and update flags. So let's just do that. And ANDing with the register. Loaded is fetch byte. Where is the AND going to go? A logical AND is performed bit by bit on the accumulator contents using the contents of a byte of memory. Does that mean it gets stored back in the accumulator? Probably. Yeah, AZN equals A and M. So CPU fetch byte and CPU.regs.and. It's not and, it's A. You should make an audiobook of this. I could hear that on long road trips. Thank you. That sounds like a compliment, I guess. The real question here is if this is supposed to fetch from the accumulator always, or from the passed-in register, which again, I don't actually think is ever going to change. So maybe we don't even need that. Let's just assume it's not going to change for now. Get rid of that. Blow this away. Blow that away. And get rid of this. And then hopefully that'll just work. I mean, I know it'll work for this once I change this bit to regs A, but the question is whether AND is going to ever show up with like AND X. Because I don't know the 8051 very well. Or this isn't an 8051, 6502. Alright, so and then comp is C9, so that worked out. Compares the contents of the accumulator with another memory. So this is just A minus M, but it only sets Z, C, and N. Actually, hang on. Does AND set carry? A, Z, N. No, okay, it doesn't. Compare. Carry is set if A is greater than or equal to M. Zero flag if A equals M. And then negative if bit 7 of the result is set. So this will be pretty easy. There's probably a better way to do this, if we're being totally honest. Like maybe implementing this as a subtraction and creating a fake register that means throw the result away is probably a better way to do this, but we'll think about it later. In general, my strategy for implementing stuff like this, or really just anything, is that I like to implement it a bunch of times manually, maybe like 3 or 4 times manually, and then try to figure out the abstraction. Even though my brain starts going off like, hey, there's a better abstraction sooner. That doesn't happen because it's compare. If So if A is greater than or equal to M would be basically if the result is positive. So I guess this is expected to be sign comparison, huh? Hi, Sai. If value is greater than or equal to 0, CPU reg C or equal flag C as you wait. Oops, that's not right. This is a P. But the rest of this should be good. A compared with divided memory. Go, go, go. Oh, okay. Fair. So this would just be if value is less than 0 in this case. Oh, and I have to actually implement it, you know. That little thing. I'm guessing there's multiple address modes. Yes, there are, of course. And so we have an AND immediate, we have a comp immediate, which is going to be C9, I believe. Yep, and now we can run it. How's it going, Sai? Having a good evening? Invalid instruction D8. Do I have a branch equal? I think I do. I know I have these. Okay, so it looks like we took the branch correctly because we ended up with CLD. I got noise and triangle channels implemented in my APU. Awesome. How long did it take you to get SMB3 running again? I know I've asked you this before. I just forgot. D. Like 3 to 4 days. Alright, you heard it here first, everyone. Sai is better than me. No one has seen that. You know what? Lila has a point. What's the auditory equivalent of Pixar It Didn't Happen? 48? That doesn't seem right. Because I definitely don't have an F8 implemented. Or do I? Oh, I do have sed. Okay, never mind. 48 is PHA. Clipser It Didn't Happen. Yeah, exactly. SoundClouder It Didn't Happen. Okay, PHA. Fa. Push accumulator is literally just push, but with an accumulator. Okay. So, PHP, right here. PHA. Exactly the same, but with an A. Hey, Sai, question for you now that you're here. So, if we look at the push instructions, like push accumulator, it says cycles 3 here, which squares with this document. But this says fetch next instruction byte and throw it away. But if I look at the trace, it only moves past the 1 instruction byte. Like it doesn't fetch 28 and throw it away. So I'm going with that. I'm just assuming that it doesn't do that and that cycle is a no-op. Does that seem reasonable? Is that like approximately what you did? I know your architecture is a little bit different. Forgot to actually implement the constant. 48. Yeah, that's pretty much what I did. Okay, so did you also run into that discrepancy, or did it just not really come up? 28 PLP, good. Is pull processor status pulls an 8-bit value from the stack and into the processor flags. That's okay, interesting. I don't currently handle UOPs, instead I execute the instruction all at once and then delay the CPU. Aren't you going to run into trouble with that? I sort of had the impression that, like, Battletoads and the like, we're not going to be super happy with that. This is going to be a problem for some games. Okay, yes. $28. Huh? Oh. There we go. Trying to go too fast. Wow, I'm up to 16 whole viewers. That's I think a new record. Thanks for stopping by, everyone. If you're not, listening in the car or whatever, say hi. Branch if minus. If the negative flag is set, then add the relative displacement. 2 plus 1 plus 2 if to a new page? Oh, no, okay, so plus 2. Alright. So, we already have branch not equal. BMI is going to be instruction 30. And it's if the negative flag is set. So, BMI is exactly the same as something like branch equals, but with the negative flag instead of the Z. Been more focused on getting all the major stuff implemented before I dive into full cycle accuracy. Yeah, I mean, that makes sense. It's not the approach that I'm taking, but I understand why you would take that approach. Certainly, it would make more sense to do that in the specific context of this challenge, as it would presumably take less time. What, cat? Why are you meowing? Come here. Fluffy, what's up? Oh, you want to go outside. Why have you started doing this? Very weird. Alright. Sorry about that, everybody. Come on, jump on my lap. Stop complaining. Come here. Oh, Fluffy boy. Oh, cool, I broke my coffee mug. Awesome. Alright, well, whatever. Okay, I think something went wrong here. Because BNE BPL. Do I have a BPL? What is a BPL? Oh, I do, because it's branch positive. And then a bunch of stuff happens. BMI, and then the next one should be BVS, which I think I already have. Yep. BCS, jump, no op, SED, LDA, STA. What am I on? It's like 9? Yeah, instruction 9. Did something go wrong or not? That does look like something maybe went wrong. I don't know that instruction 9 is a thing, but maybe it is. It's aura. Oh, it is. C88F, aura. Awesome. I'm doing better than I thought. Second guessing myself. Hi, bud. Please do not eat the shards of ceramic. Actually, everybody, I'm just going to step away for a second to clean up the shards of ceramic that are all over my floor. I'll be right back. Okay, I'm back. Sorry about that. Cat was being weird, and then when I went to pick him up, I knocked over my coffee mug. It's a whole thing, but it's all cleaned up now. It's a shame because I like that mug, but I'll just have to get a new one. I was going to do ore accumulator. Interesting. Is there an and? So and was just the accumulator, right? Match case. Was it your podcast mug? No, it was my Blue Origin mug. Gonna have to get one of my dad's friends to get me another one. Okay, so there is and, but there's no and X. But there's an or A. Is there no or X? Why is it called or A? Just to make it 3 characters? That's lame. Alright. So, where's and at? Lost track. There we go. And immediate is going to add aura immediate. Aura, aura, aura. JoJo reference. Where is it? It's going to be up here somewhere. Yeah, there we go. I've never actually watched JoJo. I probably shouldn't be culturally appropriating it. Whoops. So this one, instead of doing it in an elegant way, I'm just gonna go ahead and do it the easy way, even though I'm pretty sure there is an elegant way. I'm not sure what it is. At the moment, it'll come to mind eventually. Let's set 0 and n, which is correct. Okay, let's go. Next one. Uh-oh, forgot to change the index value. That's what I forgot to do. 0. There we go. All right, B8. This is starting to get tricky because I have a lot of the instructions implemented. I mean, it's not like I can't just control F for my program counter, but I want to make sure things are more or less correct. All right, CLV is super easy. Just clear the V flag, which I think is short for overflow. So we'll just take CLC, turn it into CLV, which is B8 instead of D8. And then down here, same exact thing. Keep those in order. This is the kind of thing that would really be better done as a macro, but ain't nobody got time for that. Actually, that brings me to a question that I've been meaning to ask anyone who is sufficiently invested to have an answer. Are the Rust parts of this at all interesting? I know I haven't been doing a lot of super interesting Rust stuff, but for example, I intend to add structured logging at some point, probably after I finish NES test. Is that something that is interesting to watch, or should I just do that off stream? I could see that being potentially not interesting. Okay, so this is Eeyore. Eeyore. Everything on stream. All right. That's what I wanted to do anyway, so I will easily take that as an excuse. What's your opcode for? Take this thing, paste it up, EOR, EOR, Aura. Same thing, except, oops, POR, and an exclusive OR here. Boop. Nice. Add with carry. If overflow occurs, the carry bit is set. This enables multiple byte addition to be performed. A plus M plus C AZCN. Set if overflow in bit 7. So this is a bad way of describing overflow, but I assume it just means if it wraps around, right? Like that's what overflow is. Shouldn't the carry bit and the overflow bit be the same in this case? All right, let's see if this has anything better to tell me. Oh, in decimal mode. Eugh. I don't want to deal with that right now. I'm sure I will have to eventually. BCD only for C64. Oh, thank goodness. I extremely did not want to deal with that. No, this does not have a better description. Oops. Decimal mode is weird. Yeah, I know. ADC code shows up in the carry and overflow flags. There's a cut trace, so you can't use BCD. Thank goodness. All right, well, let's just, you can set the decimal flag for lulz. Will it explode, or like what happens? Just nothing? Okay, so ADC, this is going to be ADC immediate, 69, the best opcode. I'm immature. The flag does get set, but it doesn't affect anything. Okay, good. I was worried it was like, I've been reading a little bit about these like test registers that you can access and just like blow up your whatchamacallit, you can just blow up your NES. Alright, so we're gonna add and we're gonna pass flags C as U8. And down here, have I added any others that actually have arguments? I do know of one such thing that damages the NES. I've gotten this, all these windows are kind of messed up now at this point. What did I change? Pull with flags. Okay, this all basically looks fine, except that I need to add the new add thing. Is there another version of add, actually? Am I just being goofy? Nope, there's only one. Alright. Didn't need to do this the way that I'm doing it, so I'm not going to do it that way. Involves putting the PPU in slave mode. What does that mean exactly? Okay, so let's create CPU regs A, and then let value equal CPU fetch flag plus CPU regs A plus, or no, let carry, is carry bit 0? I think it is, right? Status register. Carry is bit 0, so all we actually need to do, oops, is CPU regs P and 0, 1. So that's the value. We want to see if the signs have changed. So there's probably a way to do that in Rust with like just to get the sign. Or we could just mask out the sign bit, which is also pretty easy to do. So the overflow bit will be set if the signs have changed, and then the carry bit, I feel like, is just equal to the overflow bit, right? I don't see why it wouldn't be. And then the negative bit is set based on the final result. So this stays the same. This also stays the same. But we need to add 2 more cases. So we have if pre-A and 80 is not equal to pre-A, or no, it's not equal to value and 80. Then we'll set the V flag. Flags V as U8, and I guess we'll set the carry flag. So is this right? It seems like it ought to be right, but also like maybe it's not right. And also this needs to be a wrapping add. Carry calculation is wrong at least. Okay, so what is supposed to happen for carry? Is carry if bit 7 flags carry equals result greater than FF? Well, yeah. Wait, hang on. Wow, okay, that's a lot. Result is A plus value plus old carry, I guess, as a U16. So for anyone watching along at home, I'm reading what Sai says in the chat here about how to calculate the overflow flag. So if A XOR value and 80 and A XOR result and 80, so if the carry bit of A XOR value is not set, and the carry bit of A XOR result is set, then it's overflow. Okay, why? Don't really understand that. Is set during arithmetic operations if the result has yielded an invalid 2's complement result, adding 2 positive numbers and ending up with a negative result. It is determined by looking at the carry between bits 6 and 7 and between bit 7 and the carry flag. Okay, so... Okay, I get it. So, 3A XOR CPU.fetch byte, and then we'll use loaded here. Okay, you know what? You're right. Let val equal pre-A as U16 plus loaded as U16 plus CPU.regs.key as U16 and 0x01. I need to mask these also. And now I have a U16, so that'll be easier. So we'll just do val as U8, just truncates. Also, you can do what's called a pro-gamer move by having SBC just be ADC value XOR FF. Yeah. Don't you have to also negate the carry? Or no, I guess not. It depends on how the instruction is defined. Yeah. All right. Okay. So A is just the truncated thing, and then we say we probably want to just check if accumulator is 0 now, right? Yeah, if A equals 0. And then for negative, same difference. But then for overflow, or no, for carry, we want to do if val is greater than. Oh, and then this should also obviously just be CPU regs A. If val is greater than FF, U16, then we'll set the carry flag, and then for the over flag, we'll do that big crazy thing that Sai posted, which I maintain I could figure out myself, but I don't want to. Pre-A XOR loaded, and 0x80. Yeah, so this is not going to work in Rust in quite the same way, unfortunately. So what we need to do is, if this value is equal to 0 and pre-A XOR, is the result there supposed to be wrapping, or, I mean, I guess it doesn't matter. That's not how this is going to work. So, and 80 is not equal to 0, right? This is too many parentheses. Then we set the flag. Result is wrapping. Yeah, well, the as U8 is going to fix it anyway. Okay. Just make sure I did that right. So if pre-A XOR loaded and 80 is 0. So if pre-A and X and loaded are have the same negative flag, no, have different negative flags, and pre-A and the result have the same negative flag. Yeah, I'm already wrapping and writing it today. Yep. Okay, I think this is right. If it's not, that's what test ROMs are for. Okay, so let's take a look at the trace and just make sure that my flippant response about test ROMs is actually relevant. Okay, so here we go. 6969, nice. And then we get to the BMI, which is C91E. Haha, it's the sex number. Yes, exactly. Wow, it looks like a lot of stuff happens after that. Okay, so where was I? Where's the subtraction? C91C. C91C does add BMI C920 BCS, I guess. Fetch and decode is like the only one that matters, but C92C, C920, C92B. That doesn't look like it did the right thing. I don't see this going to C92B anywhere. Where does this test ROM write its failures to again? I forget. Emulator test, NES test, C0 document. 0, 2, 3. Shove the results of the test into locations 2 and 3. Okay. What does it write there if it's bad? Test failure codes and what they mean. So 0 is test completed successfully. And then, where's byte 3? Byte 3. Okay, so this is basically like, did you do the right thing, I guess? I don't think that'll matter yet. So we're just gonna add in a little check temporarily into our execute function, which says assert self dot, what did I call it? Self dot ram 002 is equal to 0. And it's gonna fail way earlier. Ha ha ha. Nope, it didn't fail at all. That's interesting. Feels like it should have. Just double check the memory map here real quick. Non-zero values, that's what I'm saying. For some reason, it also writes to 0 when reporting an error, but only sometimes, or... Alright, whatever. Let's just do this then. But then it writes to 0 for other reasons. Cool. Okay, so it explodes at C768. Which is a no-op. I should be printing instructions that get fetched. Fetch and decode. Has its own instructions. Okay, so that'll help tracing. We should probably also include the PC. Oh, and I need to subtract 1 because I've already fetched it at this point. And it should be get PC because I broke that in half. And it's not on regs. Okay. Now we're getting to do some real debugging, friends. Okay, so just decoded instruction 86 at C766, which is, of course, not even on this list. So what was the last one that worked? C764. Am I setting Z and N on LDA? Good question. Probably not. I'm supposed to be. Yeah, it's supposed to be. I'm just gonna put a tab in this so that I can actually find the instruction in my stream of log output. It looks like you're not clearing flags and the result is false. You are correct. That's exactly what I'm doing. Computer.regs.p. And equal not flag C as you ate. Z. And yes, hello cat. Boop. Boop. Alright, so we'll just go ahead and clean up all of these. So much duplicate code. Yeah, you're absolutely correct. I need to resolve that. I'll go through and fix it. Maybe after I get back to where I thought I was before in terms of everything working. And oops. I wish that Vim didn't always yank whatever you delete into the yank buffer. Like, I get why that happens, but it's kind of annoying. This really is kind of a ridiculous amount of duplicated code, isn't it? I didn't realize I had this many places that affected flags. Okay, there we go. This just goes to show you, kids. Oh, for crying out loud. %S, squiggle, exclamation point, G. Right. Thanks, Vim. %S, backslash, squiggle, exclamation point, G. I normally defend Rust, but I will say that that's a real pain in the butt and probably shouldn't have been done. Yeah, 25 viewers. This is great. It's a whole new world. Anyone who is listening, please feel free to say hello. Just because I'm talking directly to Sai about my emulator doesn't mean I don't want to hear from people who are not necessarily from the emulation Discord. All right, so let's start at the top and just go through and make sure that I did all this stuff. Road to Twitch partner. Yeah, I realized, or I looked, because they send you a summary after your stream, and I didn't realize that they just tell you what it takes to be a Twitch affiliate now. They're just like, oh, hey, here's what you got to do, and then you're an affiliate. Like, oh, okay. And it's a pretty reachable set of goals, I felt. Wasn't really something I was intending to pay attention to, but it's kind of a cool little mini target to look at. Hi, Strothj. What brings you by? Did you come from the emulation Reddit or just kind of wander by, or what's up? Requirements I remember. Yeah, you need 50 followers, an average of more than 3 viewers, to stream on 7 different days, and to stream at least 8 hours. Within a month. Within like a 30-day period. Okay, this is all looking pretty good now. Nah, I checked Science Tech for streams. That's awesome. I'm happy to hear that you happen to run into this. The basic thing going on here is that Sai, who is Sai SP, a little bit above in the chat, challenged me and several other people, I think, to implement an NES emulator within 2 weeks. And I'm trying to do that. I also decided I wanted to stream it because I used to stream and haven't in a really long time. Okay, see, that looks like I've gone off the rails because I don't see a C6 in here at all. So C7DA is RTS. Oh no, here's C600. All right. And then we end up here. Right now, I'm just trying to figure out why I'm exploding where I am and if there's actually a problem there or not. Okay, that does look wrong, C7EF. So we had C7ED, which is right here, which is branch equal. And that didn't branch correctly because the comp is wrong, I guess. Either the comp or one of these previous things is going to be wrong. I made one years ago in C#. It was fun. Yeah, it is fun. I like emulators. I like video games. I have enjoyed this little project so far. So if I had to guess, I would say it's probably push or pull that's wrong. Is that getting exercised before this point? I don't think so. So it's either push, pull, and or comp that's wrong. So let's take a look at those. Push and PHP. We do nothing. We push the processor status, and then we fetch the next instruction. We decrement S, we pull out the instruction, we set that value. That looks correct to me. Just checking here. Fetch opcode, read next instruction, push register on stack, decrement. Yep, that seems reasonable. PLA is just pull on register A, which does the wrapping add first, which I think is right, because I subtracted 1 and then I add 1, and so that makes sense. Increment and pull. For some reason that takes, whoa, what? Oh, Cortana, cool, that never happens. 27, just breaking records left and right today. Must be a good time for streaming. Welcome aboard, everybody. All right, what dumb thing am I doing here exactly? So I set it based on that. I'm not setting the flags for PLA, which it seems like I ought to probably do that. PLA, pull accumulator. Yep, PLA does set flags. So that makes sense then. Just need to do pull with flags here, and then that should hopefully resolve that issue. All right, what's next? You are the wrong document. There we go, okay. So that was ED, which is this branch, and it still is not taking the branch, so I'm doing something wrong somewhere else. So we execute pull with flags A, change register 6 to 7F, but it's supposed to be 6F. Found at 507. Oh, but we AND it with EF. So it looks like it should be correct. So either the A or the comp is wrong. I guess that couldn't have been the problem, actually, because AND and comp should set flags themselves. So that's a 7F. You and it with EF. That doesn't actually turn it into, yeah, it does turn it into a 6F. So that should be correct. As long as I implemented AND correctly, which is totally possible that I did not. Fetch byte and A becomes val. If value equals 0, set Z, otherwise don't. If value equals and 80 is set negative, otherwise unset it. That seems right. I don't know why it would be wrong. Let's check out comp. Oh, well, there you go. I wrote a comp microcode and then I just am not using it at all. Cool. Okay, so that's why. Hey, we made it past that point. All right, so now we're on C949. Back up a little ways. Let's check out C940. BVS 47, or no, 45. That doesn't seem right. Coded instruction A2 at C945. Okay, so the BVS is wrong, I guess. Either the BVS is wrong, or it's fetching too many bytes, or something. Do the flags don't get cleared after branch check, do they? Yeah, I didn't think that they would. BVS is just branch if V is set, right? So looks like 0 is not set, and overflow is set at this point. And I don't know why that would be the case, unless this ADC69 is wrong, which, I mean, that absolutely makes sense that that would be wrong. Okay, so I'm going to guess that my add sets the overflow flag incorrectly. Overfloat. Any float in a 6502 is overfloat. Gosh darn it. Initial A. Final A. Fetched. Result. So that's going to be pre-A, cpu.regs.a, loaded, and val. And then I'm going to get yelled at about bad format specifiers. Or not. Sweet. I finally learned something. Okay, so when did this happen? Here we go. Initial A is 1, final A is 6B, fetch 69, result 6B. But I still say that I did find overflow, which is not correct. Right? I don't see how that could be overflow. What is that emote, Lila? Not like this. All right. Okay. So we have pre-A XOR 80. is going to be 0. So that's correct. And then pre-A XOR the result, which is 6B, is also 80. So what am I doing wrong here? Oh, did I misalign your parentheses? Maybe. No, that doesn't seem like I did. Not A XOR value and 0x80. Oh, is it the final A or the initial A? No, result is A plus value plus old carry. So yeah, okay, it's the initial A. So then A XOR result and 80. And you want this to be 1 when it's 0 and 0 when it's 1. And you want this to be 0 when it's 1 and 1 when it's 0. Or no, hang on. 0 when it's 0 and 1 when it's 1. I don't see what is wrong here. I'm doing something incorrect. Alright, let me look at the definition again of what overflow actually is, because I think I'm probably just doing it dumb. So, set during arithmetic operations if the result has yielded an invalid 2's complement result, adding 2 positive numbers and ending up with a negative result. So basically, if you add 2 positive numbers and get a negative result, or if you add 2 negative numbers and get a positive result, that's illegal. The rest of them make sense. So all it is if the 2 signs were the same and the result sign is not the same as that sign. So let's just do if pre-A and 80 is equal to loaded and 80, and might cause precedence issues, I guess, but it shouldn't. Anyway, I'm just going to do it this way. So if their sign bits are equal and the sign bit, which is equal, is not equal to the sign bit of the result, which is val, and that's after wrapping, right? So that should be good. If the sign bits are equal and they are not equal to the sign bit of the result. That ought to work, hopefully. Except that I mess up the syntax because I have to change val back into a U8 as U8. I guess I could use the CPU register. I was still missing parentheses, you're right. Okay, so did that work? It looks like maybe. Hard to tell. What instruction was I on before? No, this one. Okay, add carry 69 was 91C. This is 9FC. Alright. Is a BCC. But we do the jumpy thing here. And we end up at CA1, which is not right. We should not take this branch. So this branch is branching when it shouldn't be branching. BCC is branch carry clear, which is correct. The immediately preceding instruction is FA, BPL, that's correct. F8 is branch equals. F6 is comp with 0. So probably either comp or load A is wrong. So we're supposed to load A with 80 and then compare with 0. And then the carry is not supposed to be set. So that's A. This is fetch, and then that's results. We just get rid of this bit. Or no, not that bit. The other bit. Unsigned subtraction, not signed. Oh, okay. Yeah, that makes sense. I don't know why I thought it was signed, but then this greater than equals to 0 is not going to be right. Or maybe it is. Maybe I want as U16 or I16. A is greater than or equal to value. Yeah, okay, that makes sense. Value being the result, not the loaded thing. Attempt to subtract with overflow. Wrapping sub. The comp instruction can take X or Y as the first operand as well. So you're saying there's like a comp X? Yep, CPX and CPY. Okay, I'll do that later. That's good to know though, thank you. So what happened here, 9EF. Looks like I maybe still exploded in the same spot. Oh no, 9FE. I didn't even make it that far. I somehow made it worse. So I executed the comp at 9E4. And then the branch at 96, 98, and then 90F. So 98 is what exploded. BPL. Why do we do BPL twice? That's a little bit weird. Forget what BPL even is. Branch if positive. So if the negative flag is not set. BPL, branch clear, flags N. So that seems right. Oh, it's because I'm using vowels less than 0. Yep. Okay, so it is negative if just this, I guess. Value and 80 is not equal to 0. Here I thought I was going to make it easy for myself. Okay, there we go. So CA2E. Oh, there we go. CA2E is an unconditional jump. CA35 is a no-op. CA36 is the bit test. And then we hit an invalid instruction. So hooray, which is load Y. Awesome. Okay, we're back in business. We fixed all of our bugs. Everything is perfect now. There are no problems. You can quote me on that. Please don't quote me on that. See how long. This is about 90 minutes. This is about as long as I was planning to stream today. I do have work in the morning and whatnot, other things to do in my life. So I think I'll go ahead and call it here. Let's make a couple notes real quick about what we're going to do tomorrow. We're going to clean up flag duplication stuff. We're gonna we're gonna finish CPU instructions. Haha. And then we're gonna add async structured logging, which is probably not gonna happen tomorrow. And we'll save this as stream notes. And that'll do it for me, everyone. Thank you so much for joining me. 26 whole viewers. That's so many. I appreciate you all taking your time out of your day to come and watch. Please stop by again tomorrow. I'll be streaming again for probably another 90 minutes to 2 hours. And I'll be doing that Monday through Thursday this week, and then do a longer stream on the weekend. So again, thanks for stopping by, and I'll see you all tomorrow, hopefully.